Today we're going to talk about section 3.5. And it's going to be complex zeros and the fundamental theorem of algebra. Okay, first thing we're going to start out with is writing down what we have been using as a polynomial. So for every polynomial, many-termed expression polynomial, p of x equals a sub n x to the n. So this is our leading term. And then each one is going to go down from there. So the next one would be a sub n minus 1, x to the n minus 1, plus, and then we'd go down n minus 2, x to the n minus 2, and so forth. So we're going to say dot, 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 plus a sub 1, x to the first, plus a sub 0. So if one of these coefficients, okay, is complex, then we have at least one complex zero. So what we're going to look at first is what did that word complex mean. So note, complex numbers are of the form a plus bi. Now, you've talked about I in Algebra 2. So I equals the square root of a negative 1. So the a is what we call the real part, and the b is the imaginary part. So an integer can also be written as a complex number. So if I have the integer negative 1, then I can make that into a complex number by just putting a plus 0i on it. So this would be an example of a complex number. So we're going to be using this idea to find the complex zeros of a given polynomial. So we're going to start out with an example. Let p of x equal x to the third minus 2x plus 4. And our job is to find all of the zeros. And the second thing is to find the complete factorization. So that factorization is the things when we put things in the parentheses, the two sets of parentheses. This one, it may be more than two, but just the idea of that. Now, before we go on, I want to take a minute to just look at this equation here. So we have a polynomial, x to the third minus 2x plus 4. So the first thing I want to ask you is, what is it going to look like? If I were to graph this polynomial, what would it look like? Well, we see that this has an x to the third and has a positive 1 in the front. So if the positive 1 in the front and x to the third, then you know it's going to be a picture of a what? Okay, like a snake shape, right? Starting low and going high. This odd number makes it the snake shape. The positive 1 makes it go from low to high, so this positive slant. Okay, so the first thing we're going to find is all the possible zeros. Now, you remember from previous sections, possible zeros means those that could be the zeros, but we don't know yet. We have to show that they are. So we set that up with that p over q. P is going to be the the factors of the constant term. And then Q is going to be the factors of the leading term. Constant coefficient, I should say, factors for the leading coefficient. So our numerator is going to be the constant, which is 4. So we're going to get plus and minus 1, plus and minus 2, and plus and minus 4. The leading term is 1, so we just have plus and minus 1. So now to find out all the possible zeros, we're going to pick from 1 divided by 1, 2 divided by 1, and 4 divided by 1 is going to give us plus and minus 1, plus and minus 2, and plus and minus 4 for the possible zeros. So what do we do with the possible zeros to find the actual zeros? Okay, that's when we use synthetic division. To find the actual. Okay, so give everybody a chance to catch up to that point first. So we're going to take our original polynomial and we're going to take the coefficients off the front. We have to remember 3, 2, 1, none, so we have a 2 missing, so we're going to have a 0x squared in our synthetic division. So we start out with 1, 0, negative 2, 4. So we're going to pick any number from this list of possible zeros to do synthetic division on. So how do we know if it's an actual 0? Well, it's an actual 0 if our remainder comes out to be 0 when we do it. So let's try 1. So if I try 1, drop my 1, 1 times 1 is 1, add and get 1, 1 times 1 is 1, add and get it negative 1, 1 times negative 1 is negative 1, add and get 3. So this 3 tells me what? That 1 is not a 0. So we have to pick another one, and we have to keep trying that until we get one of them. So we're going to try another one. So we've got 1, 0, negative 2, 4. This time we're going to pick negative 2. So I drop my 1. 2 times negative 2 gives me a negative 2. Add and get negative 2. Positive 4. Add and get positive 2. Multiply and get negative 4, and I get a 0. So in this case right here, this comes out to be 0, so we know negative 2 is a 0. But now we have, if this started with x to the third, then this is going to be x squared. So what are we going to do with the x squared? We're going to write it out first as x squared minus 2x plus 2 equals 0. But since this is a positive 2, we can't factor this. So we're going to use the what? The quadratic formula. So give everybody a chance to catch up to that point for a second first. Okay, we're continuing on from this page. So we found out so far that negative 2 is a factor. Of our polynomial, which is p of x equals 1x to the third minus 2x plus 4. So now we have to find out the rest of the factors. So we have our remainder was x squared minus 2x plus 2 equals 0. Since this is quadratic, meaning it's got a squared term, then if it won't factor, we have to use the quadratic formula. So we have a x squared plus bx plus c equals 0. And x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2a. So this is going to tell me what x is if this is, so I have 1, so ax squared plus bx plus c equals 0. Line it up, a, b, and c. So we're going to plug it in to the quadratic formula. X equals negative b, but our b is a negative 2. So we have a negative of negative 2 plus and minus the square root of b squared. So again, b is a negative 2, but make sure you put that in parentheses, negative 2 squared. Minus 4 times a, which is 1, times c, which is 2. All over 2 times a, which is 1. So now we have negative times negative gets that to be a positive 2 plus and minus the square root of, so now we have negative 2 times negative 2, which would give me a positive 4. Negative 4 times 2 is a negative 8, so 4 minus 8 gives me a negative 4 over 2. But we know that negative 4 can break into 2 plus and minus the square root of 4 times negative 1. Square root of 4 would give me 2, so I've got 2 plus and minus 2 square roots of negative 1 over 2. But we know that square root of a negative 1, from before we said square root of a negative 1 was equal to I, right? And also we can see that a 2 will come out of both of those 2, so I have 2 times 1 plus and minus, taking a 2 out, I over 2, and then the 2's would cancel. So I have 1 plus and minus I then for my other 2 factors. So my actual zeros that I needed to find were negative 2 from the previous page, 1 plus I, 1 minus I. Now, one of the things we didn't talk about before, but the polynomial, if you have a degree of the polynomial, then the number of zeros is the same as the degree. So if the degree is 3 on this one, the highest power, then that means we have 3 actual zeros. So we have 3 actual zeros. Now we have to write them as factors. Well, we're going backwards from zero product rule. You're thinking, what was it looked like to give me that negative 2? So my factors are going to be parentheses for p of x. For the first one then, what did this have to be in order to make that negative 2? Well, it would have to be x plus 2. X plus 2 and a negative 2 would make this come out to be 0. Same kind of thing on this one, 1 plus I, so it would be x minus parentheses 1 plus I. That one would be the positive, and this would be negative. And the third one is x minus parentheses 1 minus I. Now, when we have it something like this, we can't leave it like this. We want to go ahead and get rid of that inside parentheses. So we have p of x equals x plus 2. This distributes in, so I get what? X minus 1 minus I. And here we're going to do what? X minus 1 plus I. So again, what did we just say? We said that the number of factors, the number of zeros that we're going to have is determined by the degree. So the degree was 3. So we have a degree of 3. And then we also have the same number of zeros, so 3 zeros. Now, if one of the zeros occurs more than one time, so if a factor appears k times, now that could be any number, right? K is just a variable to place value. Then we say C is a zero of multiplicity k. So k is the number of times that it occurred. So give everybody a chance to catch up with that one, and then we'll try another example. So this would be the factorization, which we were looking for, and this would be the actual. So we'd probably want to circle this. Okay, we're going to try another example. So this one is P of X. So this is an example, 3x to the 5th plus 24x to the 3rd plus 48x. Okay, so our job is to factor. So we're going to factor this first by looking and seeing if there's anything in common all the way across, which we see that there is a greatest common factor. So P of X is going to be 3x out of each one of them. So if I take a 3 and an x out of this, I've got x to the 4th inside. If I take a 3 out of 24, I have an 8. If I take one of the x's out, I'm going to have x squared. And then if I take a 3 out, I get 16, and the x out, so the 16 is by itself. Now, we bring this part down, P of X equals 3x, but now this is going to be one that we can factor into two sets of parentheses, because we know 16 can be broken as 4 times 4, which adds to be 8. So I'm going to have x to the 2nd, x to the 2nd. First times each other gives me my x to the 4th. 16 is going to be 4 and 4, and then plus plus. So now we factored it. Now we're going to use zero product rule. We want to find the zeros. So we're saying, where is the polynomial going to be 0? Well, if three things multiply to be 0, then one of them has to be 0. So 3x equal to 0, x squared plus 4 equal to 0, x squared plus 4 equal to 0. So now if I divide by 3 on both sides, I get x equals 0 on this one. Minus 4 gives me x squared equals a negative 4. Same thing on this one. X squared equals a negative 4. But I don't want x squared, I want x. So I take the square root on both sides. So I get x equals 0, and then this one's going to be the square root of something squared is x. 4, again, we had like last time, the square root of a negative 4 is square root of 4 times negative 1. So square root of 4 is going to come out as a 2. Square root of negative 1 comes out as an I. But remember, when you take the square root on both sides, you have to have a plus and minus 2i. Same thing on this one, x equals plus and minus 2i. So now how many zeros do we have? We have 1, 2, 3, because we've got a plus 1 and a minus 1, plus 1 and a minus 1, so that gives me 5. So my degree was 5 of the leading term, and now I have 5 zeros. Now to write the zeros out, the way I'm going to write it is I'm going to say put this as zeros, start with the 0, then I'm going to put them out separately. So this is going to be a positive 2i and another positive 2i. Whoops, didn't mean that minus sign on there. And then a negative 2i and another negative 2i. Now the reason why I wrote them out that way is this one occurs one time. But the positive 2i occurs 2 times. And the negative 2i occurs 2 times. So this is what we were talking about a minute ago. This one is 1 time, so it says that it's going to have a odd multiplicity, or a multiplicity of 1. These two occur 2 times each, so it's going to have an even multiplicity, so that it occurs an even number of times. So multiplicity is determined by odd or even. So this would be the odd number of times, this would be even number of times. And we also again saw that there was 1, 2, 3, 4, 5 zeros, and our leading term was 3x to the 5th, so the degree is 5. Okay, I'm going to try another example. So it says find all the zeros of a polynomial. So find all zeros. So we're going to use the same techniques we've been doing. So I have p of x equals 3x to the 4th minus 2x to the 3rd minus x squared minus 12x minus 4. So we have the 4th term. This is my 4, 3, 2, 1, none. So my highest is a 4, so it's going to have a degree of 4. And so our job is first to find possible zeros. So this is the same as that previous example we did. So possible zeros is the p over q. So we said the p is the constant factors, and the q is the leading. So our constant would be 4, right? So that's going to give me plus and minus 1, plus and minus 2, plus and minus 4. And on the denominator, my leading term, I'm going to get plus and minus 1 and plus and minus 3. So now I have to do it twice. If I divide everything by 1, then I'm going to get plus and minus 1, plus and minus 2, and plus and minus 4. But now I have to come back and divide everything by 3. So I'm going to get plus and minus 1/3, plus and minus 2/3, and plus and minus 4/3. So now we're going to use synthetic division on it and see what we can come up with. So let me switch pages. So we start out with our original question, p of x equals 3x to the 4th minus 2x to the 3rd minus x squared minus 12x minus 4. 4, 3, 2, 1, none, so there's no missing ones. So we're going to start out with 3, negative 2, negative 1, negative 12, and negative 4. So we're going to pick one of the possible zeros that we have. So that's these possible zeros. So if we want to get brave and try something with a fraction to begin with, then we might try one like negative 1/3. So I start out by dropping the 3. So what do? We multiply. So we multiply 1/3 times 3. 1/3 of 3 is going to give me 1, but I have a negative, so it's going to be negative 1. So now I add these two together and get negative 3. So again, 1/3 of 3 is 1, but this time negative times negative makes this a positive 1. Add and get 0. Anything times 0 is going to give me 0, so I add and get a negative 12. So now we ask ourselves 1/3 of 12 is 4, so negative times negative gives me a positive 4, which comes out to be 0. So that tells me then that what? That negative 1/3 is an actual 0. Now with all the other ones, this one started out with x to the 4th, so this one is x to the 3rd. So when we talked about this before, we said we can't stop now. This is an actual 0, but this is now still x to the 3rd. We can't use quadratic formula on it yet. So we have to decide to put it down as another one. So we're going to start with 3, negative 3, 0, negative 12. So now you're going back to your actual zeros again. So that's these that are the actual zeros. So we pick another one, so make life easier. I'm going to go ahead and pick 2. So I draw my line, draw 3, 6, add together and get 3, 6, add together and get 6, 2 and 6 makes 12, add together and get 0. So we know that 2 is also an actual 0. So now this one was x to the third, then this one is x squared. So we're going to write it out as 3x squared plus 3x plus 6 equals 0. Now, we can see that it's not factorable, so if we want to make some smaller numbers to use instead of bigger numbers, we can see how 3's are in common all the way across. So if I take a 3 out, I'm going to get x squared plus x plus 2. 3 times x squared is 3x squared. 3 times x is 3x. 3 times 2 is 6. And now divide by the 3 on both sides. So that cancels out. So we have 1x squared plus 1x plus 2 equals 0. So this one is a quadratic, so we can use the quadratic formula on it. So this is my ax squared plus bx plus c equals 0. So I'm going to have x equals negative b, so my b is a 1, so negative 1, plus and minus the square root of b squared, which would still be 1, so 1 squared, minus 4 times a, which is 1, c, which is 2. All over 2 times a, which is 1. So now I have negative 1 plus and minus the square root of 1 minus 8 would give me a negative 7 over 2. Now, we still have the I there because we have the negative. So we're going to have square root of negative 7 is broken up as 7 times negative 1. Square root of 7 has to stay in the square root because it's not a perfect square, and the I comes outside. So we end up with negative 1 plus and minus I square roots of 7 over 2. So now, I said from beginning that the degree was the number of zeros. So our degree is 4. So we have 1 0 here, we have 1 0 here, and then we have the 2 zeros here. So if I wrote them out as my zeros, so our zeros are negative 1/3, comma 2, comma, how would we break this one up? Negative 1 plus I square roots of 7 over 2, negative 1 minus I square roots of 7 over 2. So these would be my zeros. So I'll give everybody a chance to catch up with that. We have 4 zeros and we have degree of 4. Now, one of the things that you may have noticed on some of these that we were doing so far is that our zeros come out where you have conjugates. So like on this first page, we had 1 plus I, 1 minus I. On the second page, we had 0 plus 2I, 0 minus 2I, so we had both of those in there on that one. And on the page we just finished doing, we had negative 1 plus I square roots of 7 over 2 and minus. So those are called the conjugates of each other, all right? So we're going to say that complex numbers are complex zeros. Come in conjugate pairs. So if it has a 0 of the form A plus BI, then it's also going to have a 0 of the form A minus BI. So these would be 2 zeros. So if you have one of them, then you know you have the other one. So the next example is going to take that into consideration. The example says find p of x. So this time we're creating the polynomial. Instead of having the polynomial given to us and we break it up, now we're going to build it. So with degree 3, find p of x with degree 3 has integer coefficients and the zeros of 1/2 and 3 minus I. Okay, so degree 3, this part right here, tells us then we're going to have 3 zeros. So our 3 zeros we have are 1/2, 3 minus I. That's only 2 zeros though. So what did we just say? We said any time they have one complex number as a 0, then they're going to come in pairs. So what would be my next 0 if 3 minus I was one that worked? Well, our conjugate would be 3 plus I. So now we have those written out, right? So we're going to go ahead and set it up as p of x equals, says we have degree 3, so we have 3 zeros, so we can have 3 factors. So we have three sets of parentheses. The first one, 1/2. So what makes 1/2? Well, x minus 1/2. So if I put a 1/2 into here, minus 1/2 would be 0. So we've got x minus 3 minus I and x minus 3 plus I. Now remember I told you before we don't want to leave this where the minus sign is like that. So we're going to put it as x minus 1/2, x minus 3 plus I, because negative times negative is a positive I, and x minus 3 minus I. Now, one of the things that it says is that it has integer coefficients. So in order for it to have integer coefficients, we're going to put a number on the front here that's going to make that 2 go in from a fraction into an integer. So I'm going to let this number in front be a 2. So when I distribute that 2 in, 2 times x is going to give me 2x, and negative 2 times 1/2 gives me a 1. So this would be my factored form. But we want to go ahead and multiply that out. So when we multiply it out, we're going to take 2 of them together first. So we're going to take these 2 together first. So to multiply 2 trinomials, it could be really long, or you could do it vertical method where it's a little bit more organized. So I'm going to have x minus 3 plus I times x minus 3 minus I. Now, one of the things that we can remember about I is that I squared is equal to a negative 1. So I was equal to the square root of a negative 1, but if I square both sides, I'm going to get I squared equals negative 1. So these are 2 things about imaginary numbers that you should know. Let me scoot this over so you're not off the page. All right, so we're going to go ahead and multiply. This times this gives me a negative I squared. This times this gives me a positive 3I. This times this gives me a negative IX, or XI. Now we do it to the negative 3. Negative 3 times I gives me a negative 3I. Negative 3 times negative 3 gives me a positive 9. Negative 3 times x, negative 3x. The last one is an x times I, so that gives me xi, x times the negative 3, so it gives me a negative 3x, and x times x gives me x squared. So they're all sort of lined up. So I have starting out with x squared, and negative 3x and negative 3x gives me negative 6x. The positive xi and the negative xi are going to cancel each other out, so I just get plus 9. And then this cancels out between these two. You've got a negative 3 and a positive 3 and a negative 3, so they're going to cancel out. And then I'm bringing down my minus I squared. So I squared we said was a negative 1, so minus a negative 1. So that's going to give me x squared minus 6x. But this right here is negative times negative is positive. 1 plus 9 gives me plus 10. So now we're going to take this piece and bring it up here and do what with it? We've already multiplied these two, but now we have to take this times my 2 minus I. So I've got x squared minus 6x plus 10, 2x minus 1 underneath. So I get negative 10, and then the next one gives me a positive 6x, and the negative 1x squared. So then I multiply the 2 times the 10, and I get a plus 20x minus 12x squared, and then that gives me plus 2x to the third. So I add these up, and I get 2x to the third minus 13x squared plus 26x minus 10. And that's going to equal my p of x. So let's write that a little bit better. P of x equals 2x to the third, 13x squared plus 26x minus 10. So you've created, from the original part, you've created the polynomial with those particular conditions. So that takes us through section 3.5, complex zeros. Thank you.